Hey, Hall, it's Eric Sincata and Mark Thomas with Dell Technologies and the DCWS organization, kicking off our first series of AI Safari, where we attempt to demystify and distill various relevant and AI topics into an easy to understand discussion.
Awesome. Well said, my friend. And we don't have a video today because we kind of feel like our rugged good looks might distract from the content. So we're just going to you're going to hear our voice. So hopefully that's good. Today, we're very excited to have our first guest, Dr. Randi Ludwig, a Dell Data Scientist, and a person working on some pretty cool projects. But before we jump into our topic of interpretable AI, and why it's important. Randi, would you please tell us a little bit about yourself?
Yeah, absolutely. Thanks for having me. It's a pleasure to be here. So I came into Dell as a data scientist about 5 years ago. I have since about a year and a half ago moved into a manager role. So now I'm a senior manager of the applied data science team in the services technology and strategy organization, where we work on projects that are primarily geared toward using customer telemetry data to do predictive and proactive resolution of customer issues, so that we can identify that you're having issues, what issues you're having, try to get you solutions faster, better, throughout the life cycle of a customer's engagement with Dell. And then the other thing that I do within Dell internally is I started up within the services organization, the Services Data Science Council, which is a group of, there are over a dozen teams with data scientists on them in the services organization. And so we have a weekly meeting where we get together and talk about our projects, share best practices, what we've learned, things that we can do to operate more smoothly by sharing code or tools or best practices, and then also just being a generally nerdy community that have each other's backs and to enjoy sharing this data science space together. So, yep.
Is this a pan nerdy Dell community?
This is a services specific community, but we also do engage regularly with Dell data scientists through several other networking events and best practice sharing opportunities. We watch conference talks during the Zoom COVID era. We've been doing virtual networking events on Fridays at lunchtime and stuff like that. So so we have people from marketing and supply chain, and there's people from IT, sales. So lots of folks outside of services that, yeah, that we share some of those best practices and thoughts on how our organization can continue to mature our data science capability.
Very cool.
Yeah.
Oh, it is very cool. I think that being said, Randy, one of the first questions I had was, I know in the past I've heard you mention that you really like the emphasis of using interpretable AI for changing hearts and minds, so to
Yeah.
speak. And I guess with that being said, if you could briefly explain, to the audience, what is interpretable AI? And then explain, what you mean by changing those hearts and minds.
Yeah, absolutely. So, interpretable AI. So, one of the things that's true in lots of different, so backing up just a sec, AI, data science, machine learning, kind of using those terms interchangeably here. They're all variations of toolings that data scientists use to get the job done. So I'm going to refer to them kind of interchangeably, just so you know. But anytime you're building a machine learning model, there's lots of different techniques that you can use, different kinds of models that you can build, and some of those are literally black box models. So if you use any kind of neural networks or deep learning techniques, it's not just that it's hard to figure out why the model is making the predictions it's making. It's that, like, the data scientists literally cannot interpret how the model got to where it got to. There's so many layers of complexity to the way those models are built. By design, that's part of what makes them very able to be predictive, but that also means that they're not human understandable by definition. Then that's called a black box technique. And so you put in data, you get predictions out the other side, but you're not sure what's going on in that black box to make that prediction. And in cases, there's certain types of use cases where those models work exceptionally well. image recognition, NLP tasks, various language related things. Those kinds of models can be very, very good and useful. And you can see from the results that come out the other side that they're doing a good job, but you don't quite know how they got there. So then the problem that interpretable AI solves for us is some situations are, you know if it's an image of a dog or a cat. Like you can use your human understanding of the world to, validate the model and say whether that's the right answer. But some of the things that data science gets used for are more nuanced and complex and complicated. And so you need to be able to have understanding of how the model is getting to there to be able to ensure that it's fair and to ensure that it makes sense, and bring in the domain knowledge you have of the business problem you're trying to solve to vet out and validate the results. And so one of the ways that you can do that is by using interpretable AI techniques that actually break down what's going on in that black box by doing additional models that explain what's happening with the data that you put in, or at least stimulate and mimic what the black box is doing, but in a way that gives you a readout of which parts were important. So say if I give the model a data set and it has 10,000 columns of different things that it could take into account, and I want to say, I'm making a prediction on you, Mark Thomas, what your laptop is most likely to have an issue with next. Then and you come back to me and you're like, well, why did you tell me I need a new battery? And I can go and I can be like, well, this model used columns A, Z, and 10 to decide that that was the part that you were going to need next. And so I can actually pull out the information that was most important to the model making a prediction for you. And so that becomes really important in two main use cases. I would say, coming back to the hearts and minds angle, there's both situations that our customers deal with and we deal with internally, where we're dealing with situations or customer data that's sensitive and has the ability to be potentially biased in some way. And in situations where there's a lot of risk associated with the predictions that come out of those models. So think things like the healthcare space, the finance space, things like that, where like if your model's wrong, there's real consequences to it, and it like can potentially really negatively affect people. You need to understand why your model does what it does. And so those kinds of fields have a lot more need for that interpretability, but also many businesses. I think we think of data science as being, we kind of came over the top of the hype curve. It's here to stay. People accept that AI is integrated into business and it's going to be for a long time.
Mhm.
There's value there, but at a boots on the ground level, there's still a whole lot of people who haven't had the opportunity to engage with a data science project or see AI up close. And so when you start to do projects in those different parts of the business, you're having to balance what a model is doing off of people's gut instincts and their history with having been in those business processes for a long time. And the more that you have a model that you can explain how it's working and why it's doing what it's doing, the more that you can kind of get those people over the uncertainty and uncomfortableness of not understanding this new tool to getting to a place where they're willing to integrate it into their business and their processes.
Is this? It makes a lot of sense, and I can envision businesses across many verticals being able to adopt this and really should adopt this. Um, is this something that you should apply or use as you build the model to begin with, or is it something after a model is in place that you can apply to?
Both are true. So I think for the changing hearts and minds example, I think one of the things that's important is there's a lot of kinds of modeling techniques that are interpretable by nature. And so if you're a data scientist coming into a project that is part of an organization that's kind of getting the ball rolling with data science and applying it in a way with people who haven't had that experience before, it's important to start with simple and interpretable models, even if that means, you're going to sacrifice 5 or 10% on your model accuracy. Starting with something that is 85% accurate, but you can explain to the business stakeholders is so valuable compared
Yep.
to like, oh, now it's 90% accurate because I did something, but I can't tell you how it happened. And so I think that's one of those calls that the data scientists involved in the project make. And so it's important to have the time and have the kind of ethos as a data scientist to value that communication and explainability aspect.
Yeah, I
That's a
think that
great consideration. When I hear many people talking about accuracy, it's how can I get the highest level of accuracy? But sometimes sacrificing that in the interest of driving, like you say, hearts and minds, is something to consider for
And
sure.
another one of the things about the accuracy, I continue to see this all the time, is people want, well, why would you ever sacrifice any amount of accuracy? And there's
Mm,
always trade-offs, but there's also the problem that accuracy is actually hard to measure sometimes, and it in fact may not even be the right metric to measure your model by. And so, business partners pushing for like, no, but we really need that extra 2% accuracy. Like, well, maybe what you actually need is to have fewer false positives. And that doesn't necessarily mean that your overall accuracy is going to go up, but that's, we need to minimize risk. So we're going to minimize bad predictions, that are going to say, as an example of a false positive, hey, I could predict a whole bunch of people need a new hard drive, but that's going to cost us a lot of money. So we don't want to do that unless we're absolutely sure, right? Or something like that. So there's always trade-offs. And so I think accuracy, even as the thing to aim for, is not always the whole picture.
mhm. Yeah, that's the importance of interpretable AI. It seems obvious, and even at the sacrifice to some level of the model's accuracy. Can you talk about some of the ways you've applied it? Maybe one or two examples where you've applied it within Dell.
Yeah, absolutely. So there's a project on my team right now called Smart Policy Advisor, where we get all this telemetry data back from, this is primarily gauged toward the ISG space, meaning like data centers, servers, storage, things like
Hmm.
that. And what we do is we take all of that alert data that comes back from the telemetry on the devices, and we use that as inputs to a model to predict whether an asset is going to need a part sent to them, or whether they're likely to call in about a problem. And we don't actually use those predictions. What we use is, when we put that data into the model and use it to make predictions, we get out a sorted list of which alerts are most relevant to telling me about whether someone's going to need a part or going to call in. And then we use that to go back to the team that does governance around what happens when an alert goes off. And so we use that to tell them, hey, this alert is really, really tightly correlated
Hmm.
with someone's going to call us. So we should just call them. Like, just cut to the chase. Or you know what? They're going to call us and we're going to end up sending them a part anyway. Just send the part. Like, cut the phone call out of the process. You don't even
That's
need to
awesome.
waste the time on it.
Yeah,
And so we do use the model to make predictions, but the predictions at the end of the day are not what we're using to change the business process. What we're using is that interpretable list of how the data that went into the model is being used by the model to make those predictions. So that's a
love
really
it.
good example, I think, of using that interpretable aspect specifically as the output rather than the model itself.
Yeah, I
That's really
think,
cool.
I
Yeah.
definitely see, how data science really ties back to the business. I think it's important, right? And I always say, you know, data scientists and business leaders themselves should be joined on the same mission here.
Oh, absolutely. My definition of data science, and it's a people are right to have ambiguity around it, because in the industry, even, there's not a settled standardized definition about what is data science, what is AI. Like, they're genuinely muddy terms. But I usually tell people data science is just applying the scientific method to business problems.
Mhm.
I have a background in astronomy, so I used to apply the scientific method to astronomy problems. I just pivoted and started using those exact same tools and techniques in my toolkit for the scientific method, and then started thinking about business problems at Dell, right? And so anybody who uses that scientific mindset, the analytical, logical mindset, coupled with the statistical and coding tools to be able to get to those answers, that's what data science is. And so by definition, those data scientists have to be driven by business problems, which means they need to be tightly aligned with their leaders on what are the right problems to go after in the first place.
Yep.
Yep. No,
The other thing I will say, though, in terms of that like alignment with leadership and stuff, as someone who's gone from being a practicing data scientist to a data science leadership role, one of the things that I think my background in the space has brought to my leadership practice is you can't just prioritize always based on what's going to be most helpful to the business. Like that should be your wish list. Absolutely, that's a starting point. But you have to also caveat that with what do we even have data to do anything about, which I think
Exactly.
business leaders don't often go into thinking about their problems that way. And so that's a place where there's opportunity to grow, just because there's a great quote from a really famous statistician, John Tukey, of burning desire for an answer doesn't mean the data can support that answer. And so that's kind of a grain of salt you should always take into going to approach any business problems with data science, is that some of them literally aren't going to be solvable because you may not have the data, or you may not have the right data, or even if you have some of the right data, it's not enough of it. And there's always going to be ways in which you can start to fix those problems, but that's groundwork and foundation that needs to be laid before a data scientist can meaningfully do anything to solve your problem.
Yeah,
No,
you guys wear many hats.
That-
It's amazing. You wouldn't think of a data scientist being so involved in the business process, but the more I talk to data scientists, they're very deeply involved at the business
Oh,
level.
absolutely.
Yeah.
Yeah, you need to understand that context. There's so much of, everyone thinks of science as being, it is very rigorous, but there's also creativity and art to it.
Oh, yeah.
And so
Mhm.
what you choose to go look at and what you choose to investigate and the ideas that come up to you to try is heavily biased by your understanding of the system that you're working within. And so if you don't have that context, you might go down rabbit holes and paths that are ultimately not even helpful and not realize it, right? So you need that context as a data scientist to be able to even do your job effectively.
Absolutely, absolutely. I think Matt, now on to a fun question. I hear you live in the Austin area. Is that right, Randy?
I do.
Yep. The live music capital of the world.
It's true.
Yeah. Fun question.
Yep.
What does a perfect weekend for you, your family, or just you look like in Austin?
I really love to garden. And so a perfect weekend involves me spending a whole afternoon with my arms just covered in dirt. I actually bought a truck this year to be able to haul rocks because I've been bringing in limestone to do like the edges for my raised beds for the flower beds and things that I have in the backyard and stuff. So a perfect summer weekend in Austin. I'm one of those unusual people that actually really loves the hot weather. So I thrive in Texas summers. And
you're in a perfect place then.
Exactly.
Place.
So the perfect weekend is spend part of the day digging in the dirt, planting plants, doing some yard work stuff, get all hot and dirty and covered in muck, and then like go out to the lake and water sports. And so then like it all plays together.
That's
That sounds
great.
fabulous.
Yeah, that's awesome. Well, Randy, thank you very much for joining us today, taking time out. We know you keep a busy schedule.
Yeah,
so really
thanks for having
appreciate
me.
it.
It's been fun.
Yeah, it's been fun for us as well. And for our audience out there, please stay tuned for the next podcast where we'll track down another really smart person like Randy to chat with. Thank you.
Thanks so much, everybody.